what's the underlying idea for the differential equation related to differential decay, differential growth? I mean, exponential growth, exponential decay. When, like, for a bank account, or population growth,
Well,
or radioactive decay.
it depends on one of the variables.
dp dt minus kp is equal to 0.
What's the? What I'm asking is what is the basis for making a differential equation related to exponential, like radiometric dating, or half-life of like radioactive decay? What is it?
dp over dt is equal to kp.
Right. And what are we saying here? What's the concept here?
So like the
Is that-
slope of the thing is like constantly increase. Yes, like a linear thing. So
The equation is linear, the growth is exponential,
yeah,
or the decay is exponential.
Does this have to do with the exponential factor? I mean, integrating factor?
Yeah, right. That's where exponential growth or decay comes from. Is that our integrating factor is? Do you recall what we had for integrating factor?
Yeah. E to the negative k, integral negative k.
T.
Yeah.
So our integrating factor was e to the kt. See that previous lesson on how to derive that. But this is exponential growth and exponential decay, and it's just a single differential equation. So it's slightly easier to work with. But you, instead of radioactive decay of one element, in reality, you might have like U-238 decaying into. It doesn't go straight to lead. So for this is called a radioactive series. Or a radioactive decay series. And you might have like U-238 decaying into thorium-234, and then some more steps. And then eventually it gets to lead. And this is a stable isotope. What's the matter? You don't want to do chemistry? What's the look for? What's the look for?
I got chemistry next block.
And this block.
Wait,
What's that? What's wrong?
No, it's advanced chem, not AP chem, so we don't learn the AP stuff. We just learn like whatever the students.
So you've seen radioactive. Vic.
Oh, sorry.
actually I think Vic is right.
Nah, I think
this
we're
is
the
not.
first
Vic is right, but he's not communicating with everyone in the class.
What did
I don't know what Vic said.
Leaving it at
This
that?
is
Make
not
me edit this
chemistry,
video
this
because
is
I'm yelling at
physics.
you half the class.
Oh
What?
yeah.
What?
This is not chemistry. This is physics because like it's like
What?
There's an
It's
intersection
nuclear,
between them.
nuclear chemistry, nuclear physics. It's blurry. It's blurry. It's physics.
I thought physics is like big stuff.
All of chemistry is physics.
Yeah.
All of
If you,
chemistry
like,
is physics.
Yeah, if you consider it to like the most basic level, it's just like photons and electrons.
Mr. Shado, what's going on?
These are my students. This is my students returning the wrapper to the.
It's not even open.
Oh, did it come that way?
Mr. Shado, you're getting scammed.
Yeah.
I'm sorry.
Here, you can have this one.
No mercy. Do you have any
Mr. Shado, do you speak French?
I mean,
Okay.
je parle un peu le
Do
français.
you speak German? You do.
Mhm.
Do you speak
Duh.
Italian?
I mean, I went there. I picked up enough to just for my trip, but I forgot most of it.
Why were you there?
We went with our choir. So we went to Florence and we sang all around. We went to Cinque Terre. We went to Rome.
Do you have any watermelon ones?
Yeah, there's watermelon in there. There should
There's
be.
not.
Anyway, okay, I want to get back to this.
So no watermelon.
Here.
Just do that
Here.
one quick. Yeah, man. And then
I don't know.
You only have
I think they're
45 minutes of class left.
I'm probably going to be able to tell you like 2 more sentences in 45 minutes, so let's try.
Yeah.
Are those isotopes?
This is a radioactive isotope that decays into 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 a stable isotope. So that's the end. That's the end of the chain for U-238. Is it eventually decays into lead, and as you know, radioactive half-lives are how long?
Half of a life.
How like?
70 years?
It's
Oh, we got 70 years.
It's like ln2/k or something. I forgot.
No, I mean, well, like, so how long is the half-life of a
It
substance?
It
depends on the
depends.
substance.
Some are like seconds. I think 1 or 2 like, or like minutes or something. Francium was like 2 minutes or something.
Everything on that
Oh,
bottom.
So it depends on the substance.
Yeah.
So are they long? Are they like in years? Are they in minutes? Are they like typically what could you expect?
It's years and they never like fully become non-radioactive because you're always cutting them in half.
Okay, so U-238 has a half-life of 4.5.
Uh,
That's a lot of years.
Yeah. So that's the radioactive half-life of uranium-238 is 4.5 billion years. There's some isotopes that have half-lives in a fraction of a second.
If
So-
the Earth is 4.5 billion years old, how come? Oh, it's half life, not full life. There's something.
There's nothing.
There's no such thing as full life.
No, I realized. I was like, how's there any uranium left on Earth? Like if it's 1.5.
But we're talking.
I was being half serious, and I realized it's half life.
That's great.
Forgot. Wait, how did we even get uranium in the first place?
but then after this many years, will there be any uranium left?
After this many years, the concept is that half of the material is gone.
Oh, half of the material.
That's the
Oh.
idea behind half-life, is that it takes that long for half of the material to remain. It takes another one of those periods for half of that remaining material to
So it
remain.
will never like
Because the
disappear.
radioactive decay depends on the amount of the substance. So this is kind of what you've seen before. We saw this in algebra on the growth of a bank account or radio like carbon dating. So we've seen this concept before, and we saw it in section 3.1. But let's say that we have 3 variables x, y, and z that denote the amount of substances, capital X, capital Y, and capital Z, remaining at time t. So for X, so for material X, the decay of the material X is some. Like, tell me what it is. Tell me what it is.
dx dt minus k.
So I'm gonna set up dxdt, and I'm just gonna say equals, and I'm going to so the concept of it is the rate at which it decays is proportional to what?
The amount, so just x.
The amount. It's proportional to the amount, and then I might have constants like k1, k2, and k3, but I'm going to designate them as lambda. But there's a reason why I'm going to do this is lambda 1 minus lambda 2 and minus lambda 3. So instead of proportionality, I'm going to say, Jack, why aren't you writing? I'm going to say it's equal to, and then I'm going to say the reason I'm going to write this down, and then you're going to tell me, you're going to see if you can tell me why I prefer to write this as a minus sign. What is this? What are these minus signs doing for me?
It's just showing the direction.
Yeah, it's just showing direction. It's sort of just reminding me that I'm going to have this is radioactive decay. This is not radioactive growth. This is the diminishment of my amount based on the amount that's remaining. So far so good. Nothing surprising yet.
Why is it negative K1?
I have three. I'm going to use three constants.
Okay.
So for this one, I'm going to use K2.
What is that symbol?
Lambda?
Isn't that wavelength?
It's usually
No. I'm just using it as a constant.
Okay.
Mr. Trill can't read, so he makes up random symbols. Joking.
No.
Oh, so I don't want to kill me. What do you mean?
Oh no, I'm sorry. I didn't mean to write minus K.
Okay. Okay. There we go.
There we go. If I missed your question, I apologize.
So lambda is just a variable in this context?
This is my constant of proportionality, but to be thinking of more complex systems, it's helpful for me to think in terms of what direction they're going. So I'm including a negative sign in my constant. So the concept of dx dt being proportional to the amount has not changed. The upgrading from a proportionality to equals through the use of a constant has not changed. The only thing that's changed is to make these make more sense on the page, make it more readable, make more intuitive sense. Is I'm going to include a minus sign for things that are shrinking.
Why is lambda 1?
This is exactly what I want you to think about.
Oh.
Why does this look different?
Decaying because like x decay to y and y is decaying from like x, so it has like.
Oh,
I don't get it.
you're
So
I see that, yeah.
this could be U238. This could be thorium 234, and as thorium is decaying in proportion to the amount of thorium that there is, it's also getting fed by the decay of U238. So depending on the amount of U238, my thorium grows as the decay of uranium, but it's also decaying as well. So well spotted. Was that Issa? Did you spot that? Good job. So it's gaining atoms from the decay of X, and it's losing atoms from its own decay. And then I'm simplifying this. Okay, I'm recognizing that I'm simplifying it. This is not in fact the reality because there are more steps. But let's just say, if you don't like calling it lead 206, it's just whatever stable element. So here's a radioactive element that decays into another radioactive element that decays into a stable element. Okay, so this is advisory. This is not really true because there's more steps. There's more steps in the chain, but the concept is the same. So what happens with the decay of Z?
Is it
Would it?
is it
Just whatever is in y.
Excuse me, I didn't mean to say decay. That's misleading. What is happening with the situation with Z? The amount of Z.
I feel like dz over dt equals lambda 2y minus lambda 3z.
I think it's lambda 1x.
So Z.
minus
So
lambda
the idea for Z is it's the last in the chain. It's stable. It's not decaying.
well?
Okay, so
even if it wasn't.
lambda-
Wait. One at a time. Go, Jackson.
Sure. And even if like if we did have a chain of like 5, it's always like the like minus the rate of change of the previous one, right? Like or plus.
Wouldn't it just be?
The previous ones add to it, and then
Or subtract.
it decreases from its own decay.
Because
Is it-
But Z is not decaying.
No, I'm just saying generally it was.
Is it the
it's
integral
lam-
of y?
No,
Is it
no,
lambda
it's simpler than that.
2y? Lambda 2y?
Yeah.
Okay.
Okay.
And so it's So it's only gaining elements. It's only gaining atoms from element Y. All right, you do that. I'll come around. What's a stable element? So in this example series, uranium is a radioactive isotope that decays into a radioactive isotope that decays, and finally decays into a stable element. It does not undergo radioactive decay. Lead 206 does not undergo radioactive decay. It's a stable element. You know where to start? You know where to start? You know where to start?
Well, did we
Why's your
just write the
screen so dim?
mathematical
How can
model?
you write on that? Why is your screen so dim?
Yeah, because.
Waste your battery.
Oh, it's okay. It's 86.
Where do you start?
Well, did we just write mathematical model? I'm confused by what you want us to do.
X, Y, and Z. I want you to do W, X, Y, and Z.
It's necessarily just six.
Okay, so-
Yeah,
okay,
it's
so
just,
it's gonna change
isn't
it.
it just if there's a minus?
Yeah,
Huh?
it's just like
Extra
one.
Same concept, but what does it look like? What does it look like? What would your mathematical model look like?
Are we still using the, what do we call that again?
Lambda?
Yeah, we just.
Mine-
Yeah, use lambda.
Okay.
So the y plus.
So is lambda just something, a random variable you chose?
So it is, so what is K? What is K1, 2, 3? What's K?
Constant of proportion.
And what does that do for you?
Makes it so that you don't have
So I don't have the little proportionality symbol.
to.
So the conceptual basis, the
rate.
physical reality is that the rate of change depends on the amount of substance. It's proportional. But we're gonna call it K. Maybe we know what that is. Maybe we just ignore it and use it anyway as a constant, or maybe we solve for it at the end based on initial conditions or whatever. So that's a constant proportionality that allows the proportionality to upgrade to an equality, but this can be a negative number. This is a positive number for exponential growth. It's a negative number for exponential decay. For the purpose of making it easier on ourselves to think about what's diminishing, what's growing, we're going to want to introduce a negative number here, nat. Do you want to do jumping jacks to wake yourself up?
Well, I did the problem.
But you're falling asleep.
Yeah, I did.
Sorry.
What should I just say?
Wouldn't it just be
Mine was
instant?
update one
Mhm.
and agree
Wouldn't it just
that.
be instant if you guys do it?
So is it rinse and repeat?
You can like do that.
I trust you guys more than I do, so.
So this is the
Any
thing.
cross-
This is the thing that you have to think about, because is
Maybe that's the, then maybe that's the
is
right.
X, is Y getting any atoms for W?
Actually, how I wrote that number.
Not directly, so it is rinse and repeat.
Oh, so what only matters? What only matters for y is the change in x, and we're already counting W, including
Yeah.
W in the x calculation. So it's already counted there. Yes, yeah, it'd just be, yeah, so yeah, it would be plus lambda x. I put a W out of order, but, cause I don't wanna rewrite it.
Right, so does your y have an extra term?
What?
WXY, does your third term have an extra term in it? Your third equation?
No. Has two terms.
So W decays into Y, and so Y's growth, it's gaining atoms from the decay of W. X is, right?
Is it plus?
And it's, no, this is why we want the minus sign, because we can
But I think I might
clearly
I
think
might be
of
wrong, actually.
losing atoms to its own decay,
Mm-hmm.
and at the same time it's losing atoms from its own decay,
No,
it's
I'm not
gaining atoms from the previous step.
I'm not wrong.
This
I'm
is
not wrong.
losing atoms from its own decay. It's gaining atoms from the previous step.
Oh, and then this is
I
minus.
It's nothing.
Yeah. Yeah.
So
Oh.
element W is
Remove
not
that, yeah,
decaying
I was
into
like-
I
element
see.
Y
So what's the
directly.
name of
There we,
it?
thank you, I got it.
What?
The name of the sign.
What?
Like this one. Why are you not looking at the sign?
I already looked at it.
Where's that?
What's the name?
You've already crushed my spirit.
K1 equals Is it- whatever.
Oh, it's
Is that
lambda,
correct?
it's lambda.
No.
You had it the wrong way.
Teach me, please.
So this is what the minus sign does for us.
Yeah.
Can I write on
You
it? No. No, that's fine. So W is decaying
Yes.
in proportion to its own amount. X is decaying in proportion to its own amount, but it's gaining atoms from W as W decays. So its rate, it tends to increase depending on the amount of W. That's why there's no minus sign here. That's why this is a positive amount.
Oh, okay, I see.
It's gaining atoms depending on the amount that's in X, and it's losing its own atoms through decay.
Oh, okay, so it should be like this.
That's correct for X,
But not for Y.
but not for Y. So let's pretend there was a W here. So let's pretend there's a W from here.
Okay.
Element W does not directly decay into element Y. So Y is still decaying from losing atoms from its own decay
So
and
X-
gaining atoms from the previous step,
Okay.
but the amount of W does not directly affect Y.
Okay, so it's.
There's not a third term here for Y.
Alright, so it should be this. What do you call this again?
Lambda,
Lambda.
lambda,
Lambda
LAMBDA.
2x minus lambda 3y. Right. Yeah.
Right. It's gaining atoms from the decay of X, it's gaining atoms in proportion to the amount of X, and it's losing its own atoms from the decay.
In relation to the average American, do you feel like your opinions towards the President George W. Bush is stronger, about equal, or lesser?
What do you mean, what feeling? The animosity?
Just on your opinions.
Like intensity of opinion?
The
Yeah.
magnitude of your
Yeah.
opinion towards George.
Oh,
I have strong opinions of George W. Bush.
Mm-hmm. What about Papa Bush too?
So I want to talk about Papa Bush.
Oh, you're stronger.
So Papa Bush was the commander-in-chief when I was in Desert Shield and Desert Storm, and his decisions,
You were in
caused-
Desert Storm.
I was in Desert Shield and Desert Storm.
Which one of those? I forgot what those are.
Desert Shield led into Desert Storm. They're both the Gulf War, like 1990.
Mr. Shalen,
But
you
his-
really
Wait, did
are
you
the
fight
king
the
of
Bush?
side quests, as a lot of people say.
Yeah.
Wait, Mr.
Last year I had a student say, Mr. Shady, you have too much aura.
Mr.
Well,
Um,
it's Jake's good.
But his, no, it was
Well, tell us about-
Lukey.
They'll be good.
so his decisions as commander-in-chief led to an overwhelming air campaign that meant that the Iraqi Republican Guard was wanting to surrender by the time we ground forces got there.
So you didn't get any glory.
So if getting shot at is glory, then fine. But his decisions kept my unit safe. So I have pretty strong feelings and pretty positive feelings about HW, even though I don't have positive feelings about his son. But I have positive feelings about HW.
You know, fun fact, that was before any of us
You know, look at yours
were
already.
born.
Yeah.
Yeah.
When was that?
1990.
Mr. Shadle, can I hand in the
Static.
Wait, did you work
Big
with the Kurdish
How much?
forces in the Iraq?
So the United States military forces did work with them. I volunteered to go help the Kurdish, the Kurdish people, but my major said no.
No, Mr. Shield.
What branch of the army, what branch of the military were you in?
Marine Corps.
Wait, what do you?
Why are you giving me that?
Wait,
Because I don't have to, because I wanted,
which
because you're gonna
bush did
work
the
it
no
late if I
child
upload
left
it
behind
after class.
policy?
Well, Mr.
Huh?
Shado.
No, which bush did the no child left behind policy?
No child left behind? I thought that was Clinton.
Hey,
It was
Mr.
before I was born.
Hey, Mr. Shado, what's like the coolest thing you've done in your life?
That
I
you-
taught differential equations at Fountain Valley School.
No.
Let's go.
No.
We
No.
can tell you it's not the coolest thing we've done.
用不下手了。
No, really, Mr. Shado. What about like what's the coolest thing you've done in your life?
Are you allowed to tell us
Badass.
the coolest thing you've done?
Yeah, like the most badass.
Yeah.
That's not like,
Why don't
oh,
you
I
tell us?
married a beautiful
I
wife or
coached
something.
robotics.
No.
I coached.
Something free FPS. What about the coolest thing would be free FPS like?
Okay.
Mr.
Anyway.
Shadle, this is what's happening. Your aura is dy over dx equals negative y. That's what's happening to your aura.
Yeah.
You can solve that.
What's the constant of proportionality?
It's literally just dy over dx equals negative y.
So it's
That's not good.
-1.
-1. That's not good.
No?
That's
No, you have to solve.
that's decay of aura. That's exponential decay of aura.
Yeah, exactly. Your aura is e to the negative x. E to the negative t, actually.
Wait, did you say in class that?
dA over dt equals
Yeah.
negative a.
And we're back.
Remember when we solved differential equations together when we were on the battlefield? It was stupid, it's so long, dude.
You don't know my first name.
You know your first name.
Shade, is that your first name?
How dare you?
Probably not the real one. It's probably the fake one that they gave him for like witness protection.
Yeah, Shade. That sounds like a superhero name. Kingdom Hearts, Steven Shadle.
I know it does sound like superhero.
Actually, it
It's got the comic book alliteration.
It sounds like our president. Robert Coolidge, Herbert Hoover.
What did they call you, Math Man?
No, we're doing parallel circuits.
Parallel circuits.
Wow.
Parallel circuits.
Mr. Shiro,
Hey,
I think we did that last.
Wait, yeah, I don't think it's that bad. It's just two different things.
No.
do you remember any of it?
No.
What's the law called?
No.
Vic, why am I showing you this? Jackson, what's this law called?
Jackson, you know
No,
it.
let's pursue this.
Jackson.
Jackson, you know it. What's it called? What's it called? No,
Parallel.
the law. The law.
It's L.
Kepler's law.
It's L net equals L1 plus L2. For parallel, like the resistance, the total
Isn't
is
this
L. It's
No,
all
we're cheating. You don't think a matrix story yet. Matrix.
It's first in the series. It's like 1 over. It's like.
We definitely
No, Mr. Shiro, I don't want this.
Yeah, bro.
No.
We're doing parallel circuits.
Linear algebra with FEQ. Yes. Finally, a matrix solving thing will come in handy.
Okay, so
Current in at CGP greater than V2.
I think V1 should be up top.
okay, thanks.
Can we switch C1 and A1?
No.
So it'd be 1 then, right?
Is that like node as in the discrete math node or?
Yes.
Oh, I thought it was in linear algebra node.
No, it's a. I don't know what a linear
Kirchhoff's
algebra
law.
node is. Kirchhoff's law.
How do we do this?
Two
in linear
H's,
algebra?
2 F's.
Yes, we did.
We did. What is it?
It's like he's got like a couple laws, right? He's like
I'm
Do you mean B2 or B1?
I'm confident that I'm not wasting my time teaching you this. But 1, 2, 3 of you were in linear algebra last year. 4 of y'all were in linear algebra last year. What's Kirchhoff's? Which?
So some of the products of the IR plus IR equals the voltage, and then also the
The sum of the sum of the currents equal.
the current times resistance.
Sum of parallel current equals the total current, or is it like 1 over 3?
That's it. No.
Okay.
Yeah.
Oh, why were you like? No. Is it like a cardinal bad?
No.
Okay.
There is something with circuits that it's like 1 over this equals 1 over this equals 1 over
Okay,
this.
so it's just.
But Kirchhoff's law is very straightforward. So what did we do last time? Like in unit 3.1.
We did Kirchhoff's second law.
Kirchhoff's second law said what?
It's that the inverse voltage of E of the current on a closed loop equals the sum of the voltage drop in the loop.
Right. So for example, E equaled what?
E
Just as an
equals
example.
L,
MC.
Yeah.
C squared.
No, E equals
Half MC
L
squared.
di over dt plus IR.
For example. Right. That's just for example. So this is a Kirchhoff's first law. Second law is that voltage over. Stop checking the time, Issa. How dare you? This clock is for me only.
Yeah, Jack, I've got
Yeah.
Give the one extra.
What kind of circuit is this? What kind of circuit applies the second law?
Simple.
Close.
Parallel. No. Singular.
Series.
There you go.
Oh.
Is it a ladder?
What's Kirchhoff's first law?
The current of the total current will equal the sum of all the smaller currents.
Yeah. So in this one, so I've labeled current 1, 2, and current 3. So what is Kirchhoff's first law? Use this every time you set up one of these problems in linear algebra. Every single time you started with this, Kirchhoff's first law. I1 equals I2 plus I3, or you could write them as a function. They're each functions of time. Right. And then we can also use Kirchhoff's second law here. And then what would that look like?
That will look like
So I'm going to use some of my discrete math notation, and I'm going to label this loop A1, B1, B2, A2. Which one is that?
I2.
A1, B1, B2, A2. Which loop is that?
That's the slowest one.
Oh. Sorry, this book wants me to make it a closed loop. Sorry. And that's the which one?
It's the one closest to the.
Yeah, it's the left loop. So what's Kirchhoff's second law over that loop?
E equals.
Yep.
Equals R1 I1.
Yep.
Big I1. Right. Oh, no, never mind. Big I is just. What about I2? Oh, plus I2 R2.
Nope, it's I2, no, L1 D I2
Well, I mean,
over
yeah, the order doesn't matter. So go ahead with L.
Was it?
L1
Yes.
DI2 over D.
And then go to Jackson.
Plus L2 R2. I2 R2.
Yeah.
R2D.
This is fucking.
I was just about to say that.
What do you mean R? Wait, plus R2D what?
R2D2.
Oh, it's. Oh, okay. So that's
Oh,
like
that. Oh.
D over D2.
I thought that was actually part of the equation.
Yes, I was but I was like, what the heck?
Should it, should like the I2 be negative?
No, because you're adding up all of those.
Why did you want it to be negative?
I don't know, I was following the course line.
So this is a separate concept. So over any closed loops, the voltage impressed equals the sum of the voltage drops of all the other things that we have.
Is that independent of the second one? Oh.
Yeah, these are true at the same time.
So if we consider the greater circuit, that voltage drop would be greater though.
Huh?
If we consider
This I'm drawing my bigger circuit now, so you can ask your question.
like I think if you saw them join together, the voltage drop would be greater.
Yeah. So no, I don't know if I understand your question. These are simultaneous equations.
Okay.
So e as a function of time is this, but it's also e as a function of time is also equal to, and then what's the second one?
I1 R1
I1 R1.
plus.
Wait, Jack, give me a
What?
complete this equation for me.
What we get?
I'm asking you.
Can you go scroll up a little bit?
Yes.
Okay.
So it's R dq over dt. Which one is it?
I'm asking you.
No, like I mean the
I wrote out my circuit. I labeled it in blue. It's the bigger loop.
is it 1 over c cubed?
No. No, it's not in your previous notes necessarily. I gave you the an example of how to put inductance together with the derivative of current, and put resistance together with current. These are both voltages, by the way. And this is a voltage.
Is it I1 R1 plus I3 R plus L T over dt?
Say it again.
I1 times R1.
Yeah, I1 R1 gives us this.
Then plus I3.
L2.
So current itself does not combine with inductance. The derivative of current combines with inductance.
So that's how you find the voltage drop on inductance. That's how you find.
So resistance
Yeah.
is in L2 di2 dt.
The voltage.
Yeah, and then plus L2 di3 dt, right?
Plus which?
L2 times di3 dt. Because it also passes through I3.
Oh, sorry. No. No, no, no.
There's no.
I meant to write 3 here.
Oh, okay. So you just ignored the 2?
I ignored the 2 because it's not on this loop. It's not on this loop.
Oh, okay. So even though it
So I ignored L2 when I was doing the brown loop, and I ignore L1 and R2 when I'm doing the blue loop.
So even though it passes the point, the current does not go through B1?
That's correct.
Okay.
That's correct.
Interesting.
So these are true simultaneously. Now you do the algebra.
So both of those voltage drops are the same.
So they're the same.
Oh.
So they're the same.
What's
Yeah.
this?
This is why coming at electrical circuits from a math standpoint is much easier.
There's a third loop.
It's
A1.
much easier.
There's 3 loops, so we want
Oh
3
no,
here.
that third loop doesn't go through the voltage thing.
What?
Doesn't
Oh,
have drops.
Yeah. Yeah. Technically, graphically you could think of this as a third loop, but it's not moving based on the impressed voltage from E,
Oh, okay.
from your battery or from your power source.
Well, yeah, it's not gonna go back up the resistor.
Yeah. Right. Right. So you do this part.
Well, first have to be equal to each other, and then
Yep. So what do you get?
you got L2 times di3 over dt equals L1 times di2 over dt plus 5 2R2.
So what I'm wanting to get is I want to have an expression that does not have I1. I'd like to have a system of equations
That's what I did.
in I2 and I3.
Yeah.
You did?
Yeah.
It didn't sound like it.
You just cancel
Can you
out.
tell me again?
Well,
Tell me E of T
okay, yeah.
and E of T.
It's still I1, but you can just say L2, like, you can just say that they equal each other and then put them into,
Yeah.
Yeah, I just them equal to each other.
You
Not
can set
not
you can set
not shared resistor.
yeah, you can just send the other words for,
Mhm.
Because then it would you have to subtract aside so ET minus I1 R1.
So tell me again what you got.
When I counted out ET on both sides, I got L1 DI2 DT.
L1 di2 dt.
You
Oh.
missed the I.
Uh,
You forgot the I.
di2. Thank you.
Plus I2 R2.
but you don't just, you still have I1 R1 in there, you can't just get rid of it.
All right, I'm going to tell you what I got, and you tell me if you agree.
Hmm? What is it?
I'm a little bit confused.
Is
Where are you getting this?
R1 the difference between I2 and I3? I mean, oh, I get that!
Tell me.
Because I3 is the difference between I2 and I1. So
Oh, no, I see. I see.
it would be like,
I thought you meant like literally eliminating them, because if they both equal the same thing, you.
I got you.
But then, like, you're not making this
Oh.
making it more difficult.
Huh?
You're making it more difficult.
It's less difficult. If I can eliminate I1 from my equation, my system of equations is simpler. Okay, so I'm going to, so we have 4 minutes. I'm going to draw this circuit, and I'm going to ask you to give me the system of equations.
Oh, wait, so is the old,
Uh,
You wanna start out with the E of T?
is this not exit ticket?
你是不是要保持
I want you to take 3 minutes and 45 seconds to write me a system of equations. This one is I2. This one is I3.
Wait, is this we're doing a new one?
New one. This, I want you to do this. I want you to find the system of equations. I want you to do this and simplify it and have it ready for next class.
What is that C?
Capacitance. Capacitance.
So we're doing like 2 loops, 1 inner loop, 1
One inner loop, so Kirchhoff's laws apply. So what are Kirchhoff's laws?
But then what's like what do you write for C? I know L and R, but for C what do you
What did we do last time?
how did you write?
I'm so confused on how you got rid of all the I's.
Let me see your
Go ahead.
Because, I use the difference between I1 and I2. So, if you have R1 and I2, R1 and I3, if you add them together, that's R1 and I1.
So we brought in Kirchhoff's first law.
Oh, here.
We brought in Kirchhoff's first law.
I1 equals I2 plus I3.
Is it?
I'll write that.
Let me just show you.
Hey,
Is it R times dq dt for C?
Mr. Show, can you scroll up a tiny bit? I want to see your face. Okay, thank you.
Q for C.
Can you send me the notes from last week?
last class, or last time we did this?
Yeah.
Yes. Yeah. Is it on this one? No, it's a different one.
Yeah, I'm sure you want, yeah.
The second one was the C.
Did you finish, Jackson?
Yeah.
Oh, wait, I think I get it.
Yeah, I made it. Thank you.
Like that, you substituted in there.
Yeah.
Okay, okay, so you got it.
Yeah.
You said that aha moment.
Right.
So do we need to find next class? This is
System of equations. Try to simplify it in the same way that a similar way that we did here with the making it simpler. Because the more complex it is, the harder it is to solve, and maybe we can't solve it. If it's simpler, maybe we could solve it.
Can I do integral of I full volts?
So what's the integral? What's the integral of I?
This to get rid of. So So instead of doing 1 over c cubed, I'm going to do integral I 1 over c.
So you can,
Does it need to be completely integral?
no.
Wait, I thought it's the integral q is I, not the integral I.
Okay, you know what?
No,
This is the
integral
problem for
like-
me
excuse me?
later tonight. to
So
figure out.
current is the change in charge over time.
What?
I
I
oh
Yes.
So I was
So we're doing with Q.
Huh?
So are we like
Okay.
using Q still for this one? Or do we use I?
So I'm leaving that for you as a challenge. Yeah. I'm leaving it for you. We'll talk about it next class, but I want you to try. No way.
We'll try.
No way.
gave up.
I give up.
So next on.
So what will be the next class?